Welcome back to Comp Show. Today we'll be looking into a new sorting algorithm which name is bubble sort. So bubble sort is basically not such a complicated algorithm. What it basically does is that it compares the adjacent elements of an array. It just starts from the first element and compares it with the second element. If the element, of course we are talking about ascending order sorting, if the element after is smaller than that element, it would swap. If not, it won't swap. And then the pointers will jump one indexes. Basically the pointer which was pointing on first index will jump to 2, and the one on index 2 would jump to 3, and then they will compare each other. Whichever will be the smaller will come first, and then if not, there will be no swapping. I think every time this happens depends also on the number of elements in the array, but it's a very good way. It compares one by one, so it becomes a bit recursive and long. Other than that, it's fairly simple in the explanation. So we'll straight away jump with an example for the explanation of what really happens. Thank you. Okay, so now we'll be looking in bubble sort. So bubble sort is also one of these algorithms for sorting a list or array. As you can see in the given list, we have total of 6 elements. The final answer should be something like this. It should be 10, 18, 21, 35, 62, 65. Make sense, huh? Great. So what we are doing here is that let's take the first iteration. In this sort of a sorting algorithm, one thing has to be taken very care of is that we will only be comparing the first two adjacent elements here. Okay, and the comparison would be very simple. We will check which one is the greater one, or we will check which one is the smaller one. Whichever will be the smaller one, we will swap it with the one which is greater than it. And this has been done for ascending order. If you are doing it for descending order, it's nothing much will be changed, just the sign would be changed. Simple as that. So let's take these first iteration. The first iteration is 21 and 18. Is 21 greater than 18? That's a true. So because of the fact 21 is greater than 18, we will swap these values. So now this array would look something like 18, 21, 35, 62, 65 and 10. Now since the first comparison has been done, we will do another comparison which will be 21 and 35. Is 21 greater than 35? That's a false. So no changes will be done here. We will look through the second iteration, which would be 35 and 62. So is 35 greater than 62? Of course not. So because of the fact 35 is not greater than 62, again false, no changes. We will only change if we find a element which is smaller. Because these two elements were smaller, we have made no changes until now. Let's see what has to come for the coming future. Now we have 62 and 65. Is 62 and 65 greater? Is 62 greater than 65? No. Again, we will have no changes here again. It's a very simple kind of algorithm. It's a bit lengthy again, but it gets the work done. Now the second would be 65 and 10. This is fairly simple. Is 65 greater than 10? It is. So the swap will happen. So after one complete iteration of this particular list, we will get this as the final. But as you can see, there's a bit of structure that we have got here, but it's still not completely sorted. So we will go and look for the next one. The next one would be the second iteration. This will go on until the fact that there is no adjacent element which is greater than the one for previous one. So basically every element is greater than the previous one. So now we will take this as our reference. So it will be 18, 21, 35, 65, 10, 62 here, 62, 65, this will be 62. So now again I think these are very basic, so I will be skipping it. 18 greater than 25? No. 21 greater than 35? No. 32 greater than 62? No. Is 62 greater than 10? Yes. So here, because we are getting 62 is greater than 10, that's true, there will be a swap. So now the new value of this particular list will look something like 62, 65. So this is still the iteration has not been completed. This is the new list that we have got through this iteration. Is 62 greater than 65? No. So this is the final one we get from going through the second iteration. Now we will go through the third one, which will look something like this, which will be 18, 21, 35, 60, 35, 10, 62, 65. Make sense? Great. Again, I will be skipping all those steps because now you understand what I'm doing here. 18, 21, fine. 21, 35, fine. 35, 10, not fine. So basically 10 is greater than 35 is greater than 10, which is true. So now there will be a swapping. It will be 18, 21, 10, 35, 62, 65. So this would be basically the last iteration, because if you see after this everything does fall in order, you know. So we will go for the fourth iteration here now. Fourth iteration, which would be 18, 21, 10, 35, 62, 65. Again, this is fine, this looks fine, this does not look fine. 21 greater than 10, this is true. So the new list would be 18, 10, 21, 35, 62, 65. All good here. Now I think this might be the last iteration which we'll be going through. It should be the fifth iteration. It should be comparison between 18 and 10. As we know, this does not look quite good. So we'll proceed to swap these two particular values, which will, I think, give us the final answer, which is 10, 18, 21, 35, 62, 65. Answer. Isn't it the answer that we have expected? 10, 18, 21, 35, 62, 65. So this is bubble sort algorithm explained. Okay guys, so now we'll be looking at the code of bubble sort. So it basically has the same start. We will define a function called bubble sort, and it will give an array which is passing integer. Here we will start it off with a loop for I in range length of array. Inside of it we will have another loop in range 0 and array minus 1 if arr j is greater than arr plus g plus 1, arr g arr g plus 1 equal to arr j plus 1 j return return yeah. So as you can see, we wrote the code for bubble sort and it was working. I'll be explaining why did we write what. This line basically means that this is the first loop, basically number of comparisons. This is for the unsorted element, basically the comparison value when we swap. This is the logic. If the first element is greater than the coming element, we would swap, and this is the swap code. And after the whole list iterates, it will return the array. Now here we have given this particular array, and when we ran the function, we got a sorted array. So yeah, this was the code for bubble sort. So yeah, now coming to the last part of this section, we have seen how bubble sort works, the explanation, the code. It's very simple. It basically swaps each other value, doesn't keep anything, and it's a bit long. It has a time complexity of log n square. Kindly look at the code, code it by yourself. Go on competitive programming websites like HackerRank and LeetCode and try to like solve one or two, especially the easy ones, because I think if you're understanding these concepts, easy ones will be made. So yeah, thank you for joining in. This is Mayank and you all were watching Comp Show. Take care.